Hi, in this segment, I'm going to show how the code works. So I will start with calling all the libraries. I'm going to use mostly Keras and TensorFlow for the CNN architecture and training modeling. So I'm just calling everybody. And then I'm going to read the dataset. I have named that as train FRGC, and this is the dataset called train FRGC. This is how it looks. As I told earlier, that I created multiple synthetic images by blocking, by sharpening or blurring one image. So this is how I came up with this big dataset. So I just imported that now, and then I'm going to shuffle all the data set, because whenever you read the data, they normally set it in such a way that the samples from each class is grouped together. I don't want that during training, so I shuffle the data set using this shuffle function. And then as I calculated earlier, that what should be my um, size of training dataset. If I want to have a 70s to 20s to 10 split, I should have 75,000 data from the total data. That's why I'm creating some random index values for having my training dataset, and then I'm going to use those index values. I'll show you once this. So this is called index train. That means I will go to the main file, which is this one, like where I collected the names of every person, and from this one I will just use this index number. For example, I'll choose 58,679 from this column. Like that sample will be coming into my training set. This is how I'm initializing that which index values samples will be coming into my training data set. And then I did some coding to make sure that how many classes I'm having in my training data set. So the names are like this. For example, sub 0, sample 0, blur 0. And after shuffling, this is how the names are coming. I mean the samples are coming. So for example, if the name is sub 165 underscore sample 3 underscore sharp 5, that means this is a person whose class number is 165. This is his sample where I use some sharpening. So this 3 and 5 is nothing, just some ID I kept to track that which kind of sharpening or blurring I did. These are not important, but what information important is here now. What is the exact number right after the term sub? Because this denotes the number, the label, the ID or the class number. So I'm going to obtain only this number to create labels later, because this is a supervised learning and I have to have the labels. So yeah, here I have used some dot r split function, which means split the function whenever you'll see this, and there will be in total two underscores, and I will take the leftmost one. That's why I kept 0. So I will show you how it's working. And once it's done, the number of classes in training set is 466. That means at least one sample from every class is present in the set, which is very important. And then I'm creating the labels. So creating label means, if I have a person, for example, his name is 450. Let's try with a simple one. Okay, for example, fourth one, this person's name is sub 52. That means he belongs to a class ID of 52. That means in his label everybody will be 0 except the 52 number place. I will show it. Yeah, so as I was saying, in 52 we will see a 1, like all of them are 0. I'm sorry, I went too far. Okay, yeah, this is the fourth one, and in 52 number block it's 1, because this person was a sample, is having a sample from class number 52. That's why I had only a label of 1 in 52 number index. So this is how I am getting that I'm creating the labels for training data set. And we know that there will be 21,000 data in validation data set, so that's why I'm choosing a new 21,000 index values for that. And I will try to make sure that there's no common item between the training, validation and testing data set. So this is basically checking the intersection between the trained values index and validation values index. And if this is a null vector, that means, yeah, there is no common element. If there was any common element, it should have shown that here. So in the same way, I will create validation and test data sets and their labels. So number of classes in validation set is also 466, and same goes for testing. That means at least there is one sample from every class in all of the sets, that is training, validation and testing. So this is the VGG16 model actually, which I collected from GitHub, but I adopted it. Like, I did not use the exact same thing. Like, I commented some line. That means if you uncomment that, you will directly go back to the VGC16. I don't need this many layers for my training. That's why I commented that. And I also changed this parameters. For this line means like 6 convolutional of filters were used, which were having 3 by 3 size. But in my case, uh, I sometimes play with the values. Like in their code, maybe they had 12 or 9 here, but I just changed these values according to my dataset. And yes, they always takes input which will have 2 to 4 by 2 to 4 size. So that's why I had this size uh, permanently kept in my input layer. So this is how the layer looks, the model looks like. So in total, I have 18 layers with total parameters 37,000. And in this area, I'm going to create small batches because my images are really big and there are lots of images. So if I try to import the images, all of the images together, I can't do that. I will get memory error. So I created small batches, and that's how I'm going to start the training. And if I run this, these are just creating the small batches. Now I am not going to show the epochs and the model training because it takes a lot of time. I already did that and I have my results written in a text file, so I will just show the results from that. And once the model is trained, we will just save that model for later use, or we can just instantly use the same model. This is the name of the model. I did not actually rename it. It's still called model. And then I will use the testing set and I will print the test scores. And yeah, this is the line which is doing the training. And in this line, we have to give actually the training sets, the validation sets with uh, the labels, definitely. So I will directly show the outputs. Okay, so this is the output for first fold. So I will go through epoch. So after first epoch, the training accuracy was 17% and the validation accuracy was 15%, which is very very low. So that's why I kept increasing the number of epochs. So after second epoch, the accuracy is now better, like the validation accuracy is 40%. And if I kept continuing this, like after 8th epoch, the validation the training accuracy is 86%, validation accuracy is 84%. This is how I kept changing the epoch. And after the last epoch, the training accuracy was 91% with validation accuracy 88%. And when I did the testing, I saw similar results. So after the testing, the accuracy is 89%. So the fold 2, fold 3, fold 4, fold 5, all of them are showing similar results. Like fold 2 is showing 89% accuracy, then fold 3 is 88, fold 4 86, and fold 5 86%. So I'm going to include all of this